Hello, everyone. Welcome to our afternoon session on how to monitor application performance in a container-based world. I'm Ken Owens. I'm a CTO for Cisco and our Cloud Native Platforms team, and with me is Fabio, who is one of the lead architects in the Cloud Native Platform team. Today we're going to talk a little bit about sort of what's the problem statement, what are the motivations in terms of why are we talking about this at the Cloud Native Con. We'll kind of provide you a proposed solution that we've been working on within the Cloud Native community as well as in the OpenStack community, and then we'll give you a few key takeaways and next steps. And so what's the problem statement? I kind of like to look at problem statements in terms of sort of a user story, right? So as an application owner, I want to kind of create my application to do, like, improve and be the best that it can become and most secure it can be, the best performance it can have, and want to expose and express my my sensitivities or my application intent in a set of sort of like business level objectives or business statements, and then be able to kind of monitor what my expectations of the application from a kind of a business objective against how it's actually performing in the environment, and then make real-time decisions and actions against that. And so some of the motivations are, pretty simple, right? Let's look at, how do I sort of provide real-time performance and scalability of an application against what's happening against that application in real time. And then the difficult part is sort of how do we collect the data, how do we measure the actual performance of the application when you're deploying as a set of containers, because as you know, containers are individual small pieces of source code running in different locations, and they're loosely coupled, and so be able to kind of determine how your application is performing when you have a bunch of microservices running all over the place is not a super easy thing to do. So how do you sort of collect the data, aggregate that data, and get a clear picture of how the actual application is performing, not how container 1 and container 3 are performing, but the actual application itself. And so we prototyped this in something that we call Cisco Shipped. It's at ciscoship.io. It's freely available to use and play around with. It's sort of like if you will, kind of open sourcing a test bed for figuring out how to make applications perform better. And so it's open for you guys to use and give us feedback on. This is sort of what the interface looks like. This is one of the configuration tabs in deploy. And so the whole idea of Shipped was sort of looking at, when you look at the CNCF definition of cloud native, this is sort of the microservices architecture piece. How do you compose your application? How you develop and build your services and connect to other services? And so the kind of the building piece and the deploy piece are independent of each other. So you can develop your application on your laptop or in a set of services in the cloud, and then when you go to deploy, you can create different deployment environments. And as part of that deployment configuration, in addition to like the IaaS provider and some of the information around your deployment environment, you can go into this configuration tab for policies. And the idea here is that, as you can see on the screen, you have sort of average load, you have memory usage, you have sort of the amount of network bandwidth that's being consumed. You sort of have more what I call kind of business logic around what the application is supposed to be doing, and it's more around the sensitivity of the application. It's not a specific number. You can define specific numbers, but the point of this was sort of defining more around the sensitivity. I'll get more of that in a second. And so on the right-hand side, we have policies that you define. So this is like a simple scale-up policy that when your memory hits a certain percentage, in this case 75%, you would scale up the number of containers needed to support it. You have this this graph, we kind of call it the spider graph, that lets you sort of define the limits of like how sensitive your application is to these various parameters. And the whole point of this is, like with the whole microservices architecture, is kind of focusing on what developers are trying to do. But within this graph, this is where sort of IT gets to define what's the maximum and minimum limits. And then the developer is able to sort of move those green dots within the max and min to sort of say, for my application, I want to maximize, in this case, I want to maximize, the sort of like network thresholds or the security thresholds, and I want to kind of minimize, my limits on the load average. And so you can kind of move these dots around and create your own sensitivity per application. And at the bottom of the page is where you define actions. And so we kind of showed you a scale down action that we defined here. And so the whole point of this is, as you're developing your application, you can define, here's what my application's sensitive to, and you can have sort of a policy that lets you take action when you cross a threshold to scale up that application. And then once that desire, whatever that was that caused that action to take place, is that as soon as it goes back down below a threshold, you can scale it back down. And so it sort of is trying to address that use case of, I have, a number of, amount of usage right now that's causing my application to need to scale up. Now that period is over and I can scale it back down automatically without any user intervention. And so that's sort of in the deploy tab, configuring the application policies. When you get to the run tab, this is a little bit different now. This is where you can kind of look at, for this environment I've deployed into, which in this case is a testing environment, I want to start looking at certain parameters, right? And so first off, we want to kind of point out how many containers are running, and then as you scale up, you'll see the number of containers increase. As it's scaling from 2 to 3 containers, you'll see, it'll be like a red circle saying, hey, half of them are up, the other half are coming up. Once they're all up, it turns all green like you see here. You also have the different environments you can deploy into. And so a big part of this application, model that we wanted to push out into the industry was that you shouldn't have to change your policies just based on where you're deploying to. If you're deploying to your test environment or your QA or your production, you want your policies to function the same way regardless of what environment you're in. And so you can apply the same policies across multiple environments in the exact same way. And then obviously there's a lot of microservice specific pieces that you want to be able to monitor. Like in this case, we're showing CPU and memory and disk. And then the data we're trying to monitor in this case was the network type of utilization and network load. And so that's what was causing, in this case, we're looking at memory usage and network at the same time. And so from an architecture standpoint, so to kind of give you an idea of what we're going to show, you need a measurement bus of some kind. And within that measurement bus, you're trying to collect metrics about the microservices themselves and about your host that you're running on. And in the case of microservices, we're leveraging cAdvisor and load balancer, Traefik. In the case of the host metrics, we're using collectd. The top part there, that IDM service, is important because depending on who you are as you're logging into the system, you want to be able to kind of look at metrics that matter to you. You have, we created an app intent engine to kind of manage and create policies and do analytics around the policies. And the main things we're trying to do with that app intent engine is to kind of schedule actions, to look at the security aspects around the actions, to do alarm and notification, so it doesn't just scale up your set of services without telling you this event caused me to scale up. And then trying to compound these different methods, metrics and actions across all of your different container services you've deployed. And we're leveraging Kubernetes and Marathon for sort of that action piece to go back into the system. We also wanted to kind of tie this into the social piece of it. So we leveraged Cisco Spark, which is a collaboration tool, kind of like Slack, but ties into WebEx as well. So you can kind of create meeting rooms and do video conferencing when there's an issue. So we sort of also send alerts into what we call a Spark room, so you can then kind of collaborate with your team within the Spark room to identify what the issues are. And with that, I'll turn it over to Fabio to go through the proposed solution.
Thanks. Okay. So how we solved this? We did 3 things. Because in order to have a comprehensive and understanding of your application, you need to get sources from different ways and different places. So in order for us to compare apple with apples, what we did, we used a unified measurement formats. And we didn't want to reinvent the wheel, so we used something that I used to work with in OpenStack, and there is a format very similar to Metrics 2.0, so there is a standard. And a project in OpenStack is called Monasca. So we use the Monasca format. It's a very simple format to describe measurements. So we use a single measurement format across the board. The other thing we do, we use a measurement bus. Why we want to do that? Because we want to have the ability to send measurements and have other tools to collect those measurements and operate on those and reinject them, so then we can keep data update and enable alarming and enable other function. For the measurement bus, we actually use Kafka, since it's a very strong and robust bus itself. And then compound measurement, that's the other interesting thing. So we understand that all the metrics will be enough to create alarms or to create actions. And so some of those needs to be modified by other components to create what we call compounds. So this is an example of the Monasca measure. So you see that there is a name of the measure, which will be your metric, right? And then there is a timestamp and a value. And in the middle, there is what's called dimension. Those dimensions are the specific and non-specific labels that you want to push into the metric. So these come from the Docker labels, they come. And we found out that injecting at least 4 of them, project ID, which is equivalent of a tenant ID, if you wish. Service ID refers to the microservice that belong to the project, which will be the application. And then the environment, talking about like, this is this development or this staging. And then the host where they are running. We can correlate a lot of data, and we can do a lot of things with this simple label. So of course you can attach more and integrate more. But what we discovered is with 4, you can do already a lot. And so going back a little bit into the details, when you schedule a container, you will inject those 4 labels, and that's what our Cisco ship does. And then this will be attached to the container that runs. And then we have modified cAdvisor, which not only will publish to Kafka, but we will publish using that particular format. So then we can leverage an existing component called Monasca Persister, which can take those metrics and store them into InfluxDB. And one of the beautiful things is that all these labels that are under dimensions will become automatically queryable and will be mapped into tags into InfluxDB. And if you know a little bit about time series databases, tags basically are stored once per time series, so they don't occupy space. And they will become very, very fast to query. And then because InfluxDB already has a plugin for Grafana, basically we can leverage that and go and do the views. I'm sorry, I'm a little bit out of focus those when I scale them up. I can query InfluxDB through Grafana, and I can create all sorts of queries and visualization I want on the data. And I can definitely use those labels, for instance, if a certain user to be allowed to see only the projects that belongs to me or only the services that are part of that project, and all this dicing of the data as I wish. The other thing is alarming. So I can create thresholds on any of these metrics, right? But only that. Once these metrics are identified, now you see that my application intent engine with the alarming works out of the bus itself. So I don't need to wait for the data to be stored in the database before I can create an alarm. So in this way, I have really inline alarming, which will happen at the time the measure is being written, and not by the time it's the database. Why? Because I want to decouple the time it will take to write the data to the database. So what I want to do is I want to make sure that I write a huge amount of data in a single go, so I get performance from the database, and I don't wait that time if something is happening in my infrastructure in the meantime. So then I can write things like this. I can say, if my simple app intent rule, I can say if there are these 2 things that are happening at the same time, I can go and write a new measure. So let's say, for instance, my database, my CPU memory usage is 50%. In any given day of the week, 50% is good, or it could be a problem. But when I reach maybe the weekend, or when I know I expect more workload, then that 50% is actually not a big deal anymore. So what I can do is that I can have these policies that are going to add some data, and based on this extra information, create a new metric, and then that new metric will be the one that will be evaluated for a real alarm or not. The next step we did is, in order to understand how your application behaves, especially around microservices, it's not enough to just have the traditional measurements from CPU, network, I/O, and blah, blah, blah. You also need to understand what's going on at the load balancer, because depending on the response time that you get from your microservices, there could be effects, domino effects on your application, right? Right now, a microservice is responding slowly than used to, and that will create some timeout in other microservices, and it can create some problems. So what we did, we extended Traefik, which is the load balancer we use in our solution. And again, we added from Traefik the ability to generate the same metrics, but this time on the Kafka bus itself. And on Traefik, we can get the project ID from the messaging, we can get the service ID, but we can't get the container ID because, of course, load balancing, we don't know from which container the traffic is routed or not. But that didn't stop us to make the major connection between the services so we can correlate the data. And so adding this to the pot, again, the load balancer can send the data there and doesn't change anything to our pipeline because, of course, it's in the same format, it's consumed as before, it's just a new metric is going to be shown, and it's new metrics that can be displayed on the Grafana. So now we have the ability to get response codes. So for instance, there are a lot of 500s in a short amount of time, something is going real wrong, or 400s, or 403 for unauthorized, so someone is trying to do something spooking, or maybe simply a cert is expired. That's why one microservice cannot access another one anymore. So we are now able to identify all these situations, simply creating alarms around those situations. And then we have the response time. So if we see spikes, we can capture those and say, hey, this should be brought to attention. And then we can correlate the spike with maybe that particular microservice, and the microservice may have some memory issues, increase in memory or in CPU usage, and we can do all these sort of correlations. And then lastly, we were working on doing security scan. We started with host security scan. So we had another project in Cisco called Norad, and they were kind to work with us on basically producing the same metrics in the same format. What they will do, they will periodically go and scan the hosts of the Kubernetes or the Mesos cluster, and if there were some problems, they had like a bunch of scans that will report. They will return a value from 0 to 1, saying 0 is okay, 1, there is a problem, and depending on the value, it will tell you the severity, right? What was the worst, and 0.5 means half of the tests were failed, and all this kind of stuff. So then we could use that to do things like, oh, that host didn't pass the security, there is something dodgy about it, maybe we go and just stop to use it, and then Kubernetes will move the container out. Or in case of situation where it wasn't that severe, you get something like 0.2, 0.3, what you could do, you could say, well, at this point, I have some application that will be more sensitive to security issues, so just go and talk to the scheduler and create an anti-affinity rule for that particular host, so I don't want to take any risk. None of the containers run in the host, but they will be moved to a different host. Where other applications that were less important for my business, they can keep running on that host because it's not going to be that of a big deal. And we never got to the point of doing security scan on the container live, but that was our next objective, to go and scan the containers themselves. So if you look at a complete solution, it looks like this, right? Now you have the cAdvisor for the container themselves, the load balancer. You can have both host and container vulnerability scans. You can have collectd to take the host metrics. And then, if you run on an OpenStack infrastructure, you can leverage that, or VMware or any of the other public clouds, you can funnel that data, convert those metrics into the format, and then have those to be also inserted into the pod. At that point, you will have a very comprehensive view of what's happening in your entire cloud. So takeaways and next steps. So I think what we discovered is that, as I mentioned at the beginning, with standardizing the format and adding a few labels to our microservices and applications, we were able to do a lot of correlation of the data. Have we done root cause analysis? I don't think we are there yet. I don't think it's that easy. But definitely, we extract a lot of mileage just taking care of the architecture in that way and applying very simple solutions. And so the corrective actions we can take multiple corrective actions in one go. So when there is an alarm that is set up, this has 1 to n policies associated with it. So we can currently do scaling up and down. We are working on the anti-affinity rules to move the containers around, as I mentioned before. And then the suspended execution is a very interesting one, because if you have some host compromise or container compromise, what you want to do, you want to stop the container from running, so then you can do forensics later on and look at the container themselves. And so the overall idea here is that as much as we want to interfere, as much as IT want to control, reality is that nobody else than the application owner really knows and should be in charge of dictating or understanding what are the important parameters, what should be the corrective actions for the application to be run correctly. And we want the IT department to set limits within what can be done. For instance, you cannot scale infinitely, or you cannot take a scale up to an infinite amount of memory or things like that. But beside that, it should be really the application owner to spend the cards in the right place, right? Use them in the right place. And then, he has the ability to see and monitor how the application is working, how it evolves, and what's happening. So next step, so as Ken mentioned, this technology is a POC, is meant to illustrate the capabilities and what can we do. And so what we're really looking for is to, make this concept accepted in the industry and, taking as a way forward for application owner and for defining high-level application description. So if you look at the keynote today, there were all those layers that the Cloud Native Foundation is defining. At the very top, there is a concept of application, and that's the part that we are looking here. And so not all of the features that I described here are implemented, but there is a good chunk, and you can go and test them. And as Ken mentioned, are available at ciscoship.io. So you can go there and create very simple applications, and then you can define those policies. You can have them at runtime, and you can play with the policy, the scaling, and all this kind of stuff. And I think what we really would like to do is to see what is the space within the Prometheus community to basically take an approach similar to this and make sure that we have a unified metrics, we have a bus, so we create an ecosystem where other players can consume metrics and produce metrics on the bus, and we enable all sorts of complex computation, compound computation that all go and be stored on the same system and database. Okay, and with this I'm done. So thanks, and we're here for questions, guys.